going to talk about conductors. And so we're going to turn to Bill White, who is with the CTC Global Corporation, where he is the Director of Business Development for the Northeastern U.S.
Thank you, Carol. Thanks, everybody, for coming. Do we have a lot of congressional staffers and interns in the room? Great. And people just seeking refuge from the heat? Okay, so that's about 90% by my count. So thanks for coming. Thanks for talking about something really exciting, which is transmission conductors. But I'll start by saying that I've worked on the climate change issue for many, many years, for over 25 years. And now I'm been in the electricity business for a while. And I'm convinced that one of the most important things we can do to get to a low-carbon future is to build a very strong and efficient network. Just like we have one for information, the internet, we're all familiar with that. If you're really old like I am, you can remember a time when there was something called a local area network, which was not nearly as interesting as the internet, I can assure you, or as beneficial to our economy. So I think we need, big pipes that are efficient and work well, small pipes that work well, and we need to really access all the resources like storage, like clean energy. We're going to need it all. We're going to need it all to work together at the highest level and at the smallest level, all the way down to your rooftop. So that's my preface. So the part of the system that hasn't got quite as much attention is the high voltage system, because we don't really think about it unless we're driving by a big power line and we say, oh, that's unfortunate. So I get that. But not only do we need to make that network better and more efficient, but there happens to be a number of technologies. There happen to be a large number of technologies that can do just that are on the market right now. And I'm going to talk about one of them. But there are information technologies, there are power flow controls, there are dynamic line rating. There are a lot of different technologies that are making our grid more efficient right now. But I'm going to talk about the wire itself. So for the last 100 years or so, we've been using this. And I have props, so I'm prepared. And I don't know if you can see it, but you're going to have to come visit me down the hall if you want to learn more about it. Some of you already have, I can see. And this is about 100 years old, this technology, literally the same stuff that Thomas Edison used. It's steel in the middle, and that's the structural part of it that holds it up. And then wrapped around that, the lighter colored, the shiny stuff, is aluminum, and that carries the electricity. And it's called aluminum conductor steel reinforced, ACSR. More than 95% of the high voltage wire that's in the air right now is this technology. So our company, CTC Global Corporation, we're in Irvine, California, for all the California people here in Orange County. What we did was we took out the steel, and like lots of parts of the economy, we replaced the steel with carbon fiber. In this case, it's a carbon fiber glass composite. And so we've seen it in aerospace. We see it more and more in the automotive industry. We see it in many, many industries where carbon fiber composites are replacing steel and aluminum. And this carbon fiber composite is lighter and stronger than steel. And it has the added benefit. One of the problems with this technology is that when you put a lot of power on it, it heats up. And when it heats up, it sags. And so if you've ever seen a fully loaded transmission line on a really hot day when everybody's got their air conditioners cranked up, you'll notice that it's sagging really far. And that means it's fully loaded. And that limits the amount of power that you can transmit safely on that line. Because you can't let it hit the ground. That's awful. That's really bad. Or the trees that are underneath it or something like that. You can't let that happen. So, and the other thing that happens is the repeated stressing of it mechanically, over time it becomes brittle and it doesn't bounce back and it has to be replaced because it's no longer safe. So what our product is thermally stable. It doesn't sag. It sags a little bit as the aluminum relaxes and then it stops. We can put twice as much, we can put 30% more aluminum for the same diameter and weight, and that allows us to carry twice as much power. So what's happening now on the grid, one of the big things that's happening, our power demand isn't growing as quickly as it once was. It's growing a lot more slowly, but it's growing. But the big change that's stressing the grid more than that is the flows on the grid are changing because our generation resources are changing. You're probably aware that we've closed a lot of coal generating facilities. We've added a lot of natural gas and wind and solar. And that means the grid, these constraints are popping up in places where they didn't exist before. So utilities are having to find ways to open up those constraints. We also have a lot of things that are just old and they need to be replaced. So those factors mean that if you're going to add capacity and replace this, and you need a line that can carry more power than the one you have up there now, what you have to do is take down all the towers, put a bigger, heavier version of this on it, and build bigger towers, which everyone loves, bigger towers, right? Cut down a bunch of trees, more people can see it, that's awesome. And then you put a bigger, heavier wire up there. Or you could take our product, same diameter and weight, use the existing towers, and just swap out the wire, saving, more than 3/4 of the project cost and putting a more efficient, higher capacity product in and getting your product in. So we believe this is a technology that can help us to, one of many, that can make our grid meet the challenges that we're facing now, changing power flows, slow load growth, and making the grid more robust and reliable all around. This is stronger, it can withstand storms better, it can, we had one in Oklahoma, I can show you a picture of it. An F5 tornado picked up a storage container, threw it into the power line, stripped off about 15 feet of the aluminum, but our core didn't break. A steel line would have snapped and would have taken the towers down. Ours was back up and running in a few hours. So these are the kinds of things that we think these technologies can do as we modernize not just the part of the grid that we see at our house, our efficient appliances and our solar panels and our electric cars, but the part of the grid that we don't see all the time, but that's still really important, which is the high voltage system that kind of makes it all possible. So thanks. I'm down the hall if you have any questions and you want to learn more about what we're doing. We're selling it in 42 countries around the world, and it's going great, and happy to answer any questions. Thanks.
Great, thank you. So you heard it here.